Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on February 6, 2026, just 4 days ago. It introduces a novel framework called TP-GRPO, which addresses the issue of sparse rewards in flow matching models by assigning credit to specific denoising steps rather than just the final image. The paper is titled Alleviating Sparse Rewards by Modeling Stepwise and Long-Term Sampling Effects in Flow-Based GRPO. And as we'll see later, this approach of identifying critical turning points in the generation process leads to much faster convergence and higher quality images. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the core motivation here: the instability of rewards during generation. It tracks the pick score for several trajectories across denoising time steps, moving from left to right. Notice that the colored lines don't rise smoothly. Instead, they fluctuate significantly. The arrows highlight turning points where a single step flips the trend. Orange arrows mark actions that rescue a trajectory, while blue ones indicate mistakes. Since standard methods assign the final reward to every preceding step, they fail to distinguish these specific good or bad actions. So Figure 2 breaks down exactly how the method identifies these critical moments. The top row shows cases that are not turning points. In panel A, the reward simply continues to decrease without flipping, while in panel B, the local change does not match the overall positive trend of the full trajectory. The bottom row, however, captures the actual turning points. Panel C illustrates a good turning point, where a declining path is suddenly rescued by step XT, flipping the trend to align with a successful final image. Conversely, panel D shows a bad turning point that ruins a promising generation. By pinpointing these specific reversals, the algorithm knows exactly which steps deserve the heaviest long-term rewards or penalties. So, Figure 3 puts this mechanism into the broader context of the training method. Here, we see 3 denoising trajectories, labeled I, J, and K, evolving from left to right as the time step counts down to 0. The blue spheres represent what the authors call normal points. For these, the model calculates a simple stepwise reward, measuring only the immediate incremental gain between 2 consecutive steps. But looking at the glowing yellow spheres, these are the identified turning points. For these critical moments, the method switches to an aggregated reward, indicated by the large orange brackets on the right. This means the model credits that specific turning point with the entire cumulative improvement observed from that moment until the final image is generated, effectively capturing its long-term impact. Alright, Figure 4 validates this approach by tracking training performance across 3 tasks: compositional generation on the left, visual text rendering in the middle, and human preference on the right. Consistently, the orange and green lines representing TP-GRPO climb faster and higher than the blue flow GRPO baseline. The advantage is most visible in the third chart for human preference. Here, the new method reaches a high pick score in just 700 steps, whereas the baseline requires over 2,000 steps to catch up. Well, Table 1 provides the specific numbers backing those curves, comparing TP-GRPO against the flow GRPO baseline. The results are grouped by task, starting with compositional image generation, where the Genival score improves from roughly 0.967 to 0.972. In the middle section for visual text rendering, we see a similar boost in OCR accuracy. And at the bottom, under human preference alignment, the method achieves a pick score of nearly 24.7, compared to 24 flat for the baseline. Importantly, the columns on the right confirm that general image quality and aesthetics remain stable or even improve, so the model isn't just gaming the target metric. So, Figure 5 brings these numbers to life with a qualitative comparison across the 3 tasks. The grid organizes results by method in the rows, starting with the base model at the top and moving down to the proposed TP-GRPO variants at the bottom. In the middle columns for visual text rendering, take the chalkboard example. The baseline models struggle with spelling, writing trip with 2 R's, but the proposed method renders field trip tomorrow perfectly. Then, over on the left for compositional generation, the prompt explicitly asks for 4 books, and while the baseline misses the count, the TP-GRPO model gets it exactly right. Wrapping up, 2 takeaways stand out. First, outcome-based rewards are too blunt for fine-tuning flow matching models. Second, by explicitly rewarding turning points, we can achieve higher quality generation and faster convergence without extra hyperparameters. This approach really refines how we assign credit in generative AI. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.